In this video, we're going to take a look at the law of sines. The law of sines is used if we want to find missing side lengths or angle measurements in a non-right triangle. It will also work in a right triangle. So here's what the law of sines says. Notice that the way that the diagram is shown, the big letters are the angle measurements, and they are across from the little letters that are the side measurements. So let's say we wanted to know something about an A pair and a C pair, and we wanted to solve for one of those missing components. We would just ignore the B pair and set up our ratio. We're always going to use just two items at a time when we are using our law of sines. In this first example, we want to solve for a missing side length x. You'll notice that there are no letters labeled on my diagram, so I can go ahead and label those. So it doesn't matter how I label them, but I'll choose to do this as ABC. Across from big A is little a. Across from big B is little b. So it looks like I'm dealing with an A pair and a B pair. So I'm going to use law of sines. I'll set it up as the sine of big A over little a is equal to the sine of big B over little b. All right, my A pair says the sine of 29 degrees over 11 is equal to the sine of 118 degrees over x. At this point, I'm going to cross multiply. So I have x times the sine of 29 degrees is equal to 11 times the sine of 118 degrees. I see it's x times the sine of 29 degrees. So to get x all by itself, I'm going to divide both sides by the sine of 29 degrees. The sine of 29 over sine of 29, that reduces, and I'm left with x equals 11 times the sine of 118 degrees divided by the sine of 29 degrees. I'm going to type that all into my calculator, and I end up with 20.03 as my missing side length. In this next problem, we want to solve for a missing angle measurement. Again, I don't have letters, so I can add my own in. I'm going to label my letters, my big letters as the angles, and my little letters as the side. So again, I'm going to choose to work with an A pair and a B pair. So I have the sine of big A over little a is equal to the sine of big B over little b. So I have the sine of 115 degrees over 123 is equal to the sine of big B over 16. I'm going to cross multiply now, which leaves me with 16 times the sine of 115 degrees is equal to 123 times the sine of big B. I want to get b all by itself, so I'll start by dividing each side by 123. They'll reduce on this side. And I'm left with all of that stuff is equal to the sine of big B. Since I want to get b all by itself, I need to undo sine. So I'm going to take the sine inverse of both sides. Sine and sine inverse undo each other. And I'm going to type all of this into my calculator. So I take the sine inverse of 16 times the sine of 115 degrees and divide by 123, and that leaves me with 6.77 degrees for B. In this last problem, we want to solve for a missing side length. I notice that if I'm dealing with pairs, and I can go ahead and label this as A, B, and C, across from big A is little a, across from big B is little b, across from big C is little c. Well, I have my A pair, where I'm solving for my missing side length. But if I take a look, my 11 side length is across from nothing. And my 29 degrees is across from nothing. So I'm having some issues. It looks like I have two unknowns. But keep in mind that we know something about the angle measurements in a triangle. If I take 29 degrees plus 118 degrees, I have 147 degrees. And if I subtract that from 180, I'm left with 33 degrees for angle C. So now I'm dealing with my A pair and my C pair. So I have the sine of big A over little a equals the sine of big C over little c. So I have the sine of 118 degrees over a is equal to the sine of 33 degrees over 11. Here I'm going to cross multiply, so I have a times the sine of 33 degrees is equal to 11 times the sine of 118 degrees. It's a times the sine of 33 degrees, so to undo that multiplication, I'm going to divide both sides by the sine of 33 degrees. They reduced on the left-hand side, so I'm just left with a equals, and now I'm just going to type in the rest in my calculator. And I end up with 17.83 is my missing side length.